Alright, room 2. Welcome to the second part of the Reworked Linux Fundamentals series. We'll be applying our knowledge to the first installment in this series, so I highly recommend completing that room first. Yes, we've done that. In part 2, we'll be ditching the in-browser functionality and help you get started with the fundamental skill of being able to log in and control terminals of remote machines. Not only this, but this room will also have you unlocking the potential of your first few commands by introducing you to flags and arguments, advancing your knowledge of the file system to perform more useful commands such as copying and moving files, introducing you to the access mechanisms in place to keep files and folders secure, and how to identify the things that our current user has access to, and running our first few scripts and executables. Alright, so nothing too taxing there. Let's start the room. And we're using a VPN. I guess they should, if you're using a VPN, it should say like, this is how you connect with the VPN, but I've already done it. The in-browser functionality was used in the room 1 to get you directly connected to your first ever Linux machine without hassle. In fact, the in-browser functionality uses the exact same protocol that we're going to be using today. This protocol is called Secure Shell, or SSH for short, and it is the common means for connecting to and interacting with a command line of a remote machine. We'll be deploying 2 machines in this room, your Linux machine, which I'm on, and the TryHackMe attack box, which we've just started. So, what is SSH and how does it work? Secure Shell, or simply SSH, is a protocol between devices in an encrypted form. I mean, that means the data between the two is encrypted. Using cryptography, any input that we send in human readable format is encrypted for travelling over the network, where it is then unencrypted once it reaches the remote machine, such as the diagram below. You can learn about the various types of encryption on a TryHackMe room, but for now we only need to understand that SSH allows us to remotely execute commands on another device remotely. Any data sent between the two is encrypted and when it is sent over the network, such as the internet. We've just deployed the machine, got an IP. Take note of this for now. I mean, you don't have to because it's always attached to the top. Deploying the machine, we've done that. Using SSH to log into your Linux machine. So let's get terminal. So SSH TryHackMe at 10.10.237.69. Hey. Do it. Thinking about it. Let's come back to it while it does something. The correct credentials into a valid account to log into the remote machine, and the IP address. For this room, we'll be logging into TryHackMe, whose password is TryHackMe without quotations. Yes, use the IP address of the machine displayed in the card at the top. That's what I did. Didn't like it. Alright, ping 10.10.10.10. Yeah, so I'm on the VPN. Did I type the room right? 10.10.237.69. Maybe the SSH didn't come up. Yeah, there we go. Taking its time. Yes. Cool. Right, so we're in. Once you're logged in, you'll be asked to trust the host and provide a password TryHackMe for the account, which is also TryHackMe. TryHackMe. Come on. I'll come off it. It doesn't take this long to time out and log in. There we go. Right, I've logged in. Yes. Introductions to flags and switches. The majority of commands allow for arguments to be provided. These arguments are identified by a hyphen and a certain keyword known as flags or switches. We'll later discuss how we can identify what commands allow for arguments to be provided and understanding what these do exactly. When using a command, unless otherwise specified, it will perform its default behavior. For example, ls lists the contents of the working directory. However, hidden files are not shown. We can use flags and switches to extend the behavior of the commands. Using our ls example, ls informs us there is only one folder named folder1, as highlighted in the screenshot below. Note that the contents in the screenshot below are only examples. However, after using the -a flag argument, short for --all, we now suddenly have an output with a few more files and folders such as hidden folder. Files and folders with a dot are hidden files, so if you prefix a folder, it hides it. Commands that accept these will also have a --help option. This option will list the possible options for the command that the command accepts, provide a brief description and example how to use it, so it will print like the man page. This option is in fact a formatted output which is called the man page, that's what I've just said, which contains documentation for Linux commands and applications. The manual pages are a great source of information for both system commands and applications available on both a Linux machine, which is accessible on the machine itself, and online. To access this documentation, we can use the man command and then provide the command name that we want to read the documentation for. Using our ls example, we would type man ls to view the manual page. Explore the manual page of the ls command. I'm okay, thank you. Let's do it. The completeness. There we go. Bit. What directional arrow would we need to navigate down? Down. Really? Is that a question? What flag would we use to display the output in a human-readable way? Ooh, let's have a look at this one. It's going to be a specific thing. Human readable -h. Okay.
Hello.
Hello. How are you, Christy?
Thank you for the follow.
Thank you for the follow. Alright, file system interaction continued. We've covered some of the most fundamental commands when interacting with the file system on the Linux machine. For example, how to use ls and find and cd. In this task, we're going to learn some more commands for interacting with the file system to allow us to create files and folders, move files and folders, and delete files and folders.
Fine, Ty. How's you?
Fine, Ty. I'm good, thanks. Yeah, so I've been working all day, so like I was going to stream yesterday and then JB streamed, so I thought I'll watch his stuff. And then finally got to push myself to do some streaming again. So yeah, where were we? So we're doing creating, moving and deleting. So they're giving us some other commands. We've got touch, which will create a file, make dir, which will make a directory, cp, which copies, mv, that moves, rm, that removes, and file, which determines the file type.
Really nice, D.
Creating files and folders, touch, make dir. Okay, so that's just reiterating what they do. Determining file type, okay. So how would we create the file named new note? We would touch new note. On the deployable machine, what is the type of unknown one in tryhackme's home directory? I quite like this, how it like gets you to get used to some of the common directories. So like unknown one. We need to know the file type, so file ASCII text. How would we move the file myfile to the directory myfolder? We would mv myfile myfolder. What are the contents of the folder of the file?
Cheers 11 says.
Here he is, speak of the devil.
Translated from Dutch.
We are just saying that I was going to stream yesterday, JB, and then you started streaming with Zashorno. So I was like, fuck's sake, now I've got to watch JB. Let's do some shout outs while we've got
Christy says.
Hide beers 11. D.
Nightbot says.
Please go check ads for 11 at web link. They were last playing no game.
And went through some processes after I paid for accounts and shit like that to get like a professional, I don't remember what the account is called now, site builder or something like that. This was back when that was actually in scope. And they had places that other people hadn't tested, so I tested it there and was shocked that both of them were vulnerable, like two separate places in one little area.
Ha ha ha. D.
Translated.
yeah, my bot bans me.
Nightbot says.
An enemy has been slain.
An enemy has been slain.
Double kill.
Double kill.
You don't need to mic lull.
Who else wants to shout out before I carry on? So I like to know who does streaming and that joins in these things.
Not gonna lie, fucking Jake was actually doing gens or some shit. Most likely one of us or none of us would have died there. Just fucking teammates like that, man. Go do something useful instead of sat there with your thumb up your ass.
My clips are so grand.
You're sat there with your thumbs up your ass.
Cheers 11 says.
Is that a new shout out thing you got there? I like it. Yeah, it's oh, I can't remember who does it. Shout out. It's something like Guru, I want to say. Like, I can't remember what the name is. Twitch Guru.
Yes, I'm a raging gamer.
So if you're on here, JP, there is a shout out player. There's a subscription one that will do longer shout outs. Otherwise it would just play clips that are 30 seconds long. So yeah, you just do the freebie one if you want. If you subscribe to this guy, then you get the access to the longer clip durations. But yeah, it's pretty cool. It's pretty easy to set up as well. Right, so that flag was THM file system.
Cheers 11 says.
Nice.
Continue to apply your knowledge and practice. Okay, I will do that. I love how it got like these dumb flags that just tell you to like think about things. It's like, yes. Permissions 101. As you would have already found out by now, certain users cannot access certain files or folders. We've previously explored some commands that can be used to determine what access we have and where it leads us. In our previous tasks, we learned how to extend the use of commands through flags and switches. Take, for example, the ls command, which lists the contents of the current directory. When using the L switch, we can see 10 columns, such as the screenshot below. So those are the columns. However, we're only interested in the first 3 columns. Although intimidating, these 3 columns are very important in determining certain characteristics of a file or folder, whether or not we have access to it. The file or folder can have a couple of characteristics that determine both what actions are followed and what user or group has the ability to perform the given action. Either read, write, or execute. Using SU to switch to user 2, so we can use... let's use the cmnaticpem file in our initial screenshot at the top of this task, which has the dash indicator highlighting that it is a file, and then RW followed after, which means that only the owner of the file can read and write to this cmnatic.pem, but they cannot execute. Briefly, the differences between users and groups. We explored this in Fundamentals Part 1, namely the differences between a regular user and a system user. The great thing about Linux is that permissions can be so granular that while a user technically owns a file, if the permission hasn't been set, then a group of users can also have either the same or a different set of permissions to the exact same file without affecting the file owner itself.
I look up to a text from my ex-boss about his website. Now I gotta fix it, lol.
Nightbot says.
Did you implement that thing I said where you just get the opacity to like increase by 1% every day? And now he's like, shit, my whole website's just vanished. Or has he actually paid you for it yet? And you can like bend him over a barrel now. Like, oh, you want it fixed? Well, when I see some zeros in my account. Alright, so let's put this in a real world context. The system user that runs a web server must have permissions to read.
LMFAO, I don't know what happened to it.
Nightbot says.
14 subscribers to go until we reach the goal of 15 and unlock new emote slots. Use those Prime subs if you have them. Implement Twitch votes.
Okay, shut up, Nightbot. Alright, so the system user that runs on a web server must have permissions to read and write files for an effective web application. However, companies such as web hosting companies will have to want to allow their customers to upload their own files to the website without being the web server system user, compromising the security of every other customer. We'll learn about the commands necessary to switch between users below. So to switch between users on Linux is easy, thanks to the SU command. Unless you are the root user or using root permissions through sudo, then you're required to know 2 things to facilitate this transaction of user accounts. You need to know the user we wish to switch to and the user's password. The SU command takes a couple of switches that may be of relevance to you, for example executing a command once you log in, or specifying a specific shell to use. I encourage you to read the man page for SU and find out more. However, I will cover the -L or --login switch. Simply by providing the -L switch to SU, we start a shell that is much more similar to the actual user logging into the system. We inherit a lot more properties of the new user.
You can use poof and TTS will stop.
Oh yeah, I forgot about that. I don't know, have I got it enabled? No, I don't. Let's turn it on. Poof! Cool. Alright, So we can use.
11 says.
So TG UK version of bro or friend is made, right? Low light pressure.
TGE UK version. What's that? I'm probably being really dumb. What's oh. Oh, the UK version of bro or friend is mate, right? Yeah. Alright, mate.
Christy says.
Yeah. Cool, I got it.
11 says.
The UK version of bro is made.
Well, the new one is fam. People bloody say that all the time. What up, fam? I'm older generation, so mate's much more commonplace. Thank you for the follow. MZ25. On the deployable machine, who is the owner of important? We even got, yeah, there's important. So ls-l user 2. What would the command be to switch to user 2? su user 2. Now switch to user 2 using the password user 2. Cool, that was easy. So what we had to do, just output the contents of important. What is the flag? THM su underscore user 2. Can't type today, user 2. Alright, common directories. This one's quite important. So, -etc. This root directory is one of the most important root directories of your system. I swear I just said it's important, right? The etc folder, short for etc., is a commonplace location to store system files that are used by the operating system. For example, the sudoers file highlighted in the screenshot below contains a list of the users and groups that have permission to run sudo, or a set of commands that as the root user. Also highlighted below are the password wd and shadow files. These two files are special for Linux as they show how your system stores the passwords for each user in an encrypted format called SHA-512. -var. So the /var directory, with var being short for variable data, is one of the main root folders found on a Linux install. This folder stores the data that is frequently accessed or written by services or applications running on the system. For example, log files from running services and applications are written here, /var/log, or other data that is not necessarily associated with a specific user, i.e. databases and the like. /root, so unlike the /home directory, the /root folder is actually the home for the root system user. There isn't anything more to this folder other than that understanding that this is the home directory for the root user. But it's worth mentioning as a logical presumption, it's the user would have access to their data in the directory such as /home/root by default. /tmp, so this is a unique root directory found on a Linux install, short for temporary. The /tmp directory is volatile and is used to store data that is only needed to be accessed once or twice. Similar to the memory on your computer, once the computer is restarted, the contents of the folder is cleared out. What's useful for us in pen testing is that any user can write to this folder by default, meaning once we have access to the machine, it serves a good place to store things like our enumeration scripts, because they get deleted. README, okay. What is the directory path that we would expect logs to be stored in? /var/log. What root directory is similar to how RAM works on a computer works? TMP. Name the home directory of the root user. /root. Now apply your learning and navigate through these directories deployed on the Linux machine. Yes, of course. Nice work. This room was quite theory heavy and has covered quite a range of fundamentals in getting you familiar with Linux. To quickly recap, this room taught you how to connect to a Linux machine remotely using SSH, advancing your use of commands by providing flags, switches, and where you can go to learn these things. Learn about these things for each command. Some more commands that help you that you'll frequently be using to interact with the file system and its contents. A brief introduction to file permissions and switching users. A summary paragraph of important root directories on Ubuntu Linux install and how we may be able to use the data stored within these. I encourage you to go through this room once or twice again to gain some familiarity. Yes, of course, I'll be doing that. Part 3. Part 3 of Linux Fundamentals is here. And terminate the task. And join room 3. Done. Yay!